Welcome to solverfy.
We're asked to draw a complete bipartite graph K33 on the surface of a torus so that no edges cross. So first things first, I'll just draw a torus. It's going to be a very rough drawing here, but the idea is it looks like a donut. So first we'll draw the outside, and then we also have a hole in the inside, which I'll draw like this to sort of give some perspective. And now what I'll do is draw some of the grid curves for this torus. So on the one hand we have circles going around the hole. So the closer you are here, the closer you are on the other side. So here are some of the grid curves for the torus. The other grid curves are orthogonal to these circles, and they're circles that go inside and outside the torus. So like these. And now to draw K33, well, we know this is going to have 6 vertices. So first of all, let's label these vertices into 2 different sets. So I'll partition the vertices into M, which has the vertices A, B, C, and N, which will have the vertices D, E, F. And so let's start by drawing the vertices on the torus, all in this front face. So we'll have A, B, and C next to each other. And we'll have D, E, and F in a row as well on the face of the torus. Now let's draw straight edges AD, AE. I'll do this in green. And the edges BE, BF. Sort of this zigzag pattern, and then CF as well. Alright, and then we still need to draw an edge from A to F somehow. So we'll draw a curved edge from A to F by going inside. Or instead of going inside, we're going to stay still on the face of the torus here and go in between the vertices C and F. So far, this is not different from what we would do in the plane. But now, notice that we still need to add the edge BD. And to do this, this is where we really are going to require the torus. So we'll draw a curved edge through the inside of the torus. And I'll draw this in blue to sort of distinguish this. So I'm going to start by going from D around A into the inside of the torus. And now I'll denote the other side of the torus by drawing a dashed line. We see that I come back out here and connect to B without crossing any lines. And finally, notice that we're still missing the edge CD. So we've tried going inside the torus, however we can't do that anymore, because if we did that, we would run into the edge DB. But there is another option. We could also draw an edge around the other side of the torus. So I'm starting at C. I'm sort of following these circular grid curves all the way around. And in fact, I can go on the complete other side of the torus up here. So these dashed lines mean I'm behind the torus. And then I'll come back out and I'll go underneath and connect to D. So far we have 3 edges from A. We have 3 edges from B. But we only have 2 edges from C, from F, and then also to D. So how do we get from C to E? Well, we can do something similar. All we have to do is just go around the torus again. This time we'll go all the way over to E. So, starting at C, I'm going around, and I'm going to go underneath the other edge. I'll come back out underneath the other edge, go underneath this edge, and then arrive at E, all without crossing any other edges. And now I have graphed K33 on the surface.